everyone, I hope everyone had a great lunch. I'm Heather Thacker, developer advocate at Gatling, and today we're going to talk about performance testing and how to stop doing it wrong. So this talk is called Speed, Stress, Soak, Performance Testing Without the Pain, and the pain I'm talking about today is running the wrong test and learning nothing useful. So this is something that many of us have probably lived through. Everything's on fire, everything's melting, production is a disaster, and everyone looks around and says what happened, all the tests they passed, everything worked in staging, and they're technically right, like the test they did pass, but the problem is they didn't test the right thing. They ran a quick load test, saw green, and then moved on, but then the system really just couldn't handle a normal day of production traffic. And that's what we're talking about, making sure that you're answering the right question before you pick the test. So, what is performance testing anyway? First, it might be easier to cover what performance testing is not. It's not functional testing. It's not unit tests or end-to-end tests. Those tell you if the code is working. For example, checking to see if the button does what it's supposed to when the user clicks it. Performance testing is more about how the system behaves under realistic traffic conditions. So this is when maybe a lot of users at the same time click those buttons. So it's really about the realistic user behavior, including the think times, the sessions, the journeys. And the goal here is to proactively find the problems before the users do. Because otherwise, the users, they become impatient and they leave when that checkout function takes 10 seconds. So basically, performance testing answers the question of whether the system works when a lot of people use it at the same time. However, there are many ways to answer that question or to ask that question, and each time you ask that question, it gives you a different answer. So what we're covering today is the testing types and when and why and how to use them. Glad everyone's settled in now that we've covered what it is. So the first one we'll start with is load testing, the one that everyone probably already knows, which establishes the baseline by checking if the application can handle 100% of expected traffic. An analogy we can use here is like a coffee shop on the weekday during the morning rush. We kind of roughly know how many customers are going to show up. So employees are scheduled, beans are stocked, the pastry case is full, and a load test will check whether the shop runs smoothly given that predictable traffic. Load testing, it often finds response time degradation, throughput bottlenecks, and SLA breaches that happen under normal conditions. It won't tell you where the system breaks. That's a different test that we'll get to shortly. And here, a common mistake that we see is the load tests are run with made-up numbers. So throwing 1,000 users at a load test, it might sound fun and be nice, but why 1,000? So if you're not modeling these tests from real production traffic derived from monitoring analytics or whatever you have in place, and your load tests are kind of useless. You're testing a scenario that doesn't really exist. So I'm including an injection profile visual and some JavaScript code as an example for each testing type to give you a few different ways to visualize these different scenarios. And this one, with all these scenarios, we'll just assume that like the average load is 100, so 100% is 100 users just for easy examples. So in this case, we're ramping up to 100 users and holding it there for about 30 minutes and then ramping back down. And this shape is a ramp up, plateau, and then ramp back down. And this is something you can run on every deploy, part of your CI/CD pipeline to have like a health check for every merge. Next one we're going to cover is stress testing. So this one looks like 150, 200, 300% of your average traffic and holding it there for many hours. And the question we're asking here is, where does the system break? So we can think of this as like a gym workout gone wrong. If you just keep adding weight to the bar, trying to find the limit, and at some point the form breaks down, your muscles hit failure and you can't finish the rep, then you would need help from your spotter. So the stress test is a spotter for your system. And what does this find? It shows resource exhaustion, cascading failures, and most importantly, whether the system can recover when the load drops back down. So the recovery part is something that is massive, but a lot of teams miss that aspect. Another common mistake we have here is running at the expected traffic load without really stressing it out. So the whole point here is to go beyond what you know to be normal with production and trying to break the system. In the code example here, we have 2x your average, so 2 or 3x. We hold it for 2 hours. So the injection profile shape is very similar with the plateau, but then it's just longer. You're sustaining that pressure to see what's really cracking under stress. We can run this before like high traffic events, product launches, maybe Black Friday if you're e-commerce, whenever you have stakes that are higher than usual. Next one is spike testing, which is a bit dramatic. It goes to 300% of your average load, but it arrives in seconds. And it will ask if we can survive a sudden massive traffic spike. So if we picture a highway at the beginning of a holiday weekend, it's normal traffic in the afternoon, but when everyone is off of work, they really hit the highway and it becomes gridlocked in seconds. And that sudden wall of demand is what the spike testing simulates. The difference here from stress testing is the speed of the increase and not just the magnitude. So the system might be able to handle 300% of traffic fine if it's gradual, but what about 300% arriving in mere seconds? We often see this with e-commerce, big events, and also streaming with crazy sports and shows and things. So spike testing, it can help find auto-scaling lag, and if your infrastructure reacts fast enough. And we can also uncover connection pool exhaustion, database lookups, and slow recovery or cascading failures after the spike. A common mistake here is testing the ramp up and then ignoring the ramp down. So recovery is half the test, because if it takes 30 seconds for everything to recover, then that's probably like graceful enough. But if it takes 30 minutes of cascading failures, then you probably have a production disaster. So the code here, it ramps up to 300%, 300 users per second in 10 seconds, holds for 30 seconds, and then ramps back down to average. And in the code, we hold that for about 15 minutes, where we can observe the recovery window. You're watching what happens after the spike and not just during it. And this chart, it shows the sharp triangle spike, quick up, quick down, which is a bit different than the plateaus of the last two. Okay, so testing, we have a few more. This one is also called endurance testing, and it's 100% average load, but for multiple days. So the question here is, what will break over time that looks perfectly fine in short tests? So we think about a car on a long road trip, a quick commute in your neighborhood or to work is no problem, but if you're driving 20 hours straight, as we like to do in the US sometimes, different problems start to show up, like a slow oil leak, or the temperature gauge starts to creep up to be too hot, or something starts rattling after 8 hours. And these are problems that you don't really catch on a short drive, and it also happens with software. So soak testing will catch the memory leaks, where the app slowly consumes more and more memory until the garbage collector starts to thrash, or processes start to crash, and it also catches resource leaks, thread deadlocks, log files, filling disk, and response times drift as the cache is bloat. The biggest mistake that we see here is that just not running the soak tests long enough. So if the memory leak takes 12 hours to show up, then it's not going to show up on a 2-hour soak test. So you really need to match the test duration to the development cycle. Code looks simple, same shape as a load test, but just much longer. So 100 users per second, constant for 2 days in this case. Long, flat plateau, looks pretty boring, but the bugs that it can catch are pretty expensive sometimes. So it's nice to run this monthly, quarterly, or before big production pushes. Last one that we're going to cover in detail is capacity testing. And this one has incremental steps and then holds at each step, something like 100, 150, 200, 250, 300% of average traffic. And the big question here is, how much runway do we have for growth? So we can think of this as adding tables to a restaurant. If you have a kitchen, it works fine at 20 tables. Add 5 more, still probably okay. Add 5 more, it starts to slow down. 5 more, and then the orders are late, food is cold, kitchen is overwhelmed, people are unhappy, they write bad reviews, they leave. So capacity testing, it maps that out for your system as well. So if stress testing is asked, where do we break today? Then capacity testing is asking, when will we need to invest for growth in the future? So it finds the scaling inflection points, these moments where production degrades non-linearly. It identifies the infrastructure ceiling and gives you the data that you need to have for the budget conversations with your team for future growth. And a common mistake that we see here is doing this once and never again, which is a fallacy because your system is always changing with every release. So that capacity model from 6 months ago may be stale. And so building the lightweight capacity testing is nice for quarterly planning, and it's also a fallacy to think that because you're in the cloud, it's going to handle everything. There's actually a lot of cases where you're overusing or underusing resources and you're paying for things that you don't need or won't need. Code example here uses increment users per second, stepping up 50% every hour or so across 5 different levels in a staircase pattern, and each step is a bit of a plateau where we can measure and understand, observe how the system is behaving at that plateau. So you can really plot how performance changes at each level. So this is a pretty different shape than anything we've seen so far. A few bonus types that are worth mentioning. This one is a smoke test. It's the simplest and easiest way to start with a simple single user to check the basic functionality. Does the system respond? Do I hit my endpoints? We can think of this as flipping the light switch before testing the whole electrical system. So we run this in the CI pipeline before every other performance test just for a sanity check. No point running a full load test if there's something broken in deployment or your tests are misconfigured. And another fun one to mention is the breakpoint test, which continuously ramps from 0 all the way up to 5, 10x your average load over a shorter period. So you don't really hold at any level here. You just keep increasing until the system fails. And you can add a stop criteria as well if you don't want to take down your whole production in this process. And the difference between stress testing and this one is stress will hold at the high level to see how the system behaves under that pressure, and breakpoint will just keep climbing until everything breaks or something breaks. It's a faster way to find your hard limit. So here's a really chaotic, ugly graph to look at with the 7 profiles overlaid on one chart. The important thing here is to see that they're all different. That's the point. Flat line at 100 is the load test and soak test, same shape, different durations. High plateau is stress. Short, sharp spike is the spike test, and the staircase is capacity. Tiny little blimp in the corner is the smoke, and the diagonal line climbing over time is breakpoint. Each shape simulates a different scenario, and each one reveals something different about your system. No single test tells the whole story here. Here's the same information, but a lot less chaotic looking. This is just a little reference point. So notice the range of durations and users from instant to multiple days, or 1 user to 500 per second. We have smoke and load tests that are your everyday tests to run on deploys. We have spike and stress, which are a little more event-driven in special use cases. Soak and capacity that are really nice for the long game tests to run monthly or quarterly. And then each test we have here, it answers a different question about the system, because performance testing, it's not just one thing, it's a toolkit, and each one has its own job. So what is the takeaway? The takeaway here is performance is a feature, and whether you're a developer, a tester, an engineering manager, it is actually your problem. So your users, they probably won't file a bug report for slow apps. They will just leave and go to competitor. So 1 second delay in a page load drops conversion by 7%. A 3-second delay loses over half your mobile users. You'll never see it in your functional tests because the functional tests use 1 user on a fast network. So if you already test functionally, then you already have CI pipelines, and adding a performance test is just one tiny step. You don't have to start with all 7 test types. You can start with a load test and model it from your real production traffic. You can hook it into the CI and see what you learn. And then when someone is asking, can we handle the Black Friday traffic spike, you know which tests to reach for. Same with your app running fine in staging, but then after a week or so in production, it crashes. We can then reach for a soak test. The pain here is not in performance testing. It's actually from running the wrong test and getting an answer to a question that nobody is asking. So first, ask the question and then pick the test. That is all I have. I ran through it a little faster because I like to talk fast when I'm in front of people. So thank you all for listening. I'm Heather from Gatling, and if you want to chat about performance testing, or if you play Pokemon Go, then come find me later or after the talk. Here are some ways to connect. I added the URL down there if you don't trust QR codes. And we also have a few openings at Gatling in marketing and sales if you're interested in working with me. Thank you all for your time, and I hope you enjoy the rest of DevOps UK.